Now, in this video, we'll be talking about operational amplifier as comparator. Now, comparator, the name itself suggests is that you are going to compare, and what you are going to compare is you are going to compare some AC signal with DC signal. Now, this AC signal uh, and this DC signal, this AC signal uh, this AC signal uh, is the it is basically the input signal, and this DC signal is it's the known signal, it's the known voltage or reference voltage. And the signal that's input, which has to be compared with the reference voltage, uh, its nature is alternating, and the the reference voltage with which we have to compare this AC signal uh, is the DC signal. Now, if I look for a simple operational amplifier, and it has two terminals, and this is VI, say for example, and this is VR. So then we will have the output, and we better understand that in addition of all the things that are here, we are biasing these operational amplifiers. So we have positive VCC and we have negative VCC. Now, to make a reference here, to understand the situation here, in order to understand that how we compare the signals, how we compare the reference signal with the known with the unknown signal. So for that, we can have conditions here, and these conditions are like, if I say here that if I say this VI is greater than VR. Now, if this VI is greater than VR, then obviously the negative part will be large, right? So in that case, we will have the output. The output will be VCC, right? Now, if I have VI less than VR in this situation, we will have so if VI is less than VR, that means overall we will have, in the previous case it should have been negative, and in this case it will be plus VCC. Now the reverse is also possible. The reverse is also possible. Suppose I give VI to the non-inverting terminal of the amplifier, and I give VR to the inverting end of the operational amplifier. So what's going to happen in that case is, if I have VI greater than VR, so now my VI is this and VR is this. In that case, I will say that that the overall output will be positive. It will be plus VCC. And if we have VI less than VR, for this situation, when this terminal is VI and this terminal is VR, In that case, now Vi is less than Vr means your V out must be minus VCC. So this is the technical way of understanding that how we are going to get the output by making a comparison between the reference voltage and and the unknown signal that we are making use of here. Now, we have two types of comparators. One is oh, uh, we have two types of comparators. One is non-inverting comparator, and second is inverting comparator. So, so this is how the situation looks like till now. So now, how would I would like to revise the concept that I talked about. In case of using operational amplifier as a comparator, we have two modes of inputs, and the main job here is to compare. That's why we call it comparator. And we have a reference voltage which is always DC in nature, and we have a signal which is AC in nature, and this voltage has to be compared with the reference voltage, right? And then we talked about the conditions that can evolve if we assume that VR is less or Vi is less, in which case the output voltage will be negative VCC, in which case the the output voltage will be positive VCC. And for that, we talked about the two conditions that are involved, uh, where we just interchange it, the positions of input and reference voltage, and we saw in the previous case what under what conditions we will have negative VC, and under which conditions we will have positive VCC. Now, now on moving on, we have to go with the non-inverting comparator. And if I seek a diagram like this, having some output and and input, okay, and I want to see the outcome of this circuit by making a comparison between the reference voltage and the signal and the AC signal that we are going to subject to this kind of formulation. So then after that, we would like to have uh, a plot between the voltages, right? Now, talking about uh, the positive terminal here, uh, if I make use of a resistance and use a signal and call it as Vi, right? So this input is given to the non-inverting terminal of this operational amplifier, and then we have the negative terminal, okay, and we have to give the fixed voltage, the DC voltage, so it has to be positive. So here I have VR. Okay, so here we are going to get the output voltage. Now if I try to seek what am I going to get here. Okay, and here I will have a load resistance and I will ground it, say this is RL, and here we have plus VCC and here we have minus VCC. Now if if VI is greater than VR, if what VI is greater than VR, so what we expect plus VCC from here, right? And if VR is greater than VI, in that case I am going to have an output of minus VCC. This VCC we also call it as saturation voltage. Okay, so we should look for some numbers here so that we can understand the concept. Okay, so I think till now it should be clear. The symbols should be clear and the situation should be clear. And let me have this resistance as R, this resistance as R. Okay, this resistance as R. Now say this is VI. So this VI is in the form of a sinusoidal wave. So this will be its peak voltage, say Vp, and this will be its minus Vp. Now if I take Vp equal to 10 volt and VR I take 4 volt. So reference voltage I will choose here, say this is VR equal to 4 volts, and let me draw a straight line here. Okay, so we can see the points here where there is intersection between the reference voltage and the signal, and here it is again like this, and here is another point of intersection, so we can draw a straight line here, and here is another intersection and we can have a straight line. Now this is my time axis, so this is T, and this should be T, and this is V out. Okay, now here we have plus VCC and here we have minus VCC. Now you can see from here to here the voltage that we have, it is less than that of the reference voltage. Now till that we will get an output of minus saturation. So it will go like this, right? Now if we go from here, move on and come back to this point, so between these 2 points, if you can compare it with the equations that I have shown here, from here to here you can see a positive a positive step, right? And then it goes down. Okay, then it goes down and then comes back to this point, and you can see, so from here to here we will have minus VCC, and it will go up to this. All right, so then you can find the same thing for this half cycle in this fashion. So this should be the output of this arrangement, that the conditions are there, and we have taken uh, an arbitrary value for V peak equal to 10 volts, and we have taken VR equal to 4 volts. So we can see that there are changes from plus VCC to minus VCC. So the output that we are going to obtain, it between plus VCC and minus VCC. So we can see we have taken a non-inverting operational amplifier, and we have made arrangements in such a way that it marks the comparison of two signals that we have already discussed. Now we can repeat the same process, the same outcome, the same comparison that we did for simply changing the arrangement for positive and negative. Now we will try the same thing for VI at this inverting terminal, and VR for the non-inverting terminal. And when we analyze, we will have the same kind of so we will have the symmetry of the output will be same, but certainly there will be difference in the directions of plus VCC and minus VCC. And if I have to immediately go for that kind of circuit, I would like to draw that at least. In that case, we will have an operational amplifier. Okay, so here, we have the signal, we have the resistance, and we have the signal, and here with the positive terminal we have the reference voltage. Okay, so there is a resistance, and we have a ground here, and then we have V out, and we have plus VCC here, and we have minus VCC here. All right, and so what will be the condition that we can have here? This is R, this is R, and here I have VI, and here I have VR, right? So I can go for similar analysis here, and if I say VI is greater than VR, so I will have minus VCC output here. If I say VI is less than VR, here I will have plus VCC. And and if I do the same kind of analysis as I did in the previous case, what will I expect is this is my signal part, right? And so this is my V and this is T, and so here we will have a situation like this. It will be like this. It will be like this. So the output behavior for simply exchanging the VI and VR and making the non-inverting terminal of the operational amplifier as the reference terminal, and inverting point of the operational amplifier as the input signal. Now, in this case, the output behavior that we will see will be opposite to that of what we achieved for the previous case.